or if you didn't grab it. Now, you're stuck on these problems here. It says 24 equals negative 6/7 u. We talked about ones yesterday that look like this. 33 equals 3u. What did we do to solve those?
The 33 divided by 3.
Exactly. We just divided by 3 and we got 11. But now we're working with fractions. It's the same thing. I have something right in front of my variable. This means negative 6/7 times u. To get rid of this, we're going to take 24 and we're going to divide it by that negative 6/7. So then this is what they did. When we divide with fractions, we end up inverting and multiplying. So we make it 24 over 1 times negative 7/6, right? And then we say, oh, 6 goes into here once and into here 4 times. 4 times negative 7 is negative 28. So here's what they did. When you looked at the LX explanation, they said 24 is equal to negative 6/7 u, and right away they went times negative 7/6 times negative 7/6 so that they could cancel that out and cancel that out. Because they're dividing, they end up inverting and multiplying that fraction.
That's why it was so confusing, because yeah, that's probably exactly what it looked like. I was like, huh?
So I don't like it that they skipped this step, because you have to know, I'm really dividing by a fraction, and then I follow my rules. So I'm not going to skip that step.
Thank you.
I'm going to do it. Now this one looks a little bit different because they made it into one big fraction instead of a second fraction. But this really is the same thing as negative 7/5 v equals negative 14. Doesn't matter if that v's on top or v's behind it, it's still the same thing. So I want to get rid of the negative 7/5. I'm going to do that by dividing by negative 7/5, right? That is multiplying. When I move it over, I divide. And so when I divide, I'm going to take negative 14 times negative 5/7 because I've got to invert and multiply.
So I'm going to go 14 over 1 though.
Yep.
Times 5/7.
And then I can reduce, right?
1 and 2.
And then when I multiply, I get
Negative 10.
negative 10. Nope. I don't get negative 10.
2 times 5.
Negative 2
there's
times negative 5.
Negative 14. Yeah.
No,
Okay.
no, the 2 times 5 part is 10, but a
So
negative times a negative is a
Positive.
positive 10. Now, if I were checking that out, it would mean I'd have negative 7 times 10 over 5, right? Putting the 10 in for the v. 7 times 10 is 70. 70 divided by 5 gives me negative 14. That's how I would check that. I'd put that number in for the variable, and since 7v means 7 times v, that's how I check it. Now then they do this to you. Sometimes the fraction is not in front of the variable. Sometimes it's just a plain number in front of the variable. Everybody gets so used to, oh, I got to flip the fraction, got to flip the fraction, got to flip the fraction. But in this case, what am I doing? I'm moving the 5 to the other side, so I'm taking negative 15/7 divided by the 5, right? The 5 is the one that I want to get rid of. What do I do?
That?
Because I have 5w and I want to get w by
Oh,
itself.
because the equal, so it would be on the, it
So-
would be the answer that you're dividing by. Okay.
Right,
Okay.
that's what I'm dividing by is the 5.
Okay.
So if I'm going to divide by 5, I'm going to multiply by
You're gonna go times 1/5.
Exactly is what I'm gonna do. And then I'm gonna do some reducing. 5 goes into there once and into there 3 times, and so W is gonna equal
-3.
-3/7, right? -3/7. So that's what happens is they take those shortcuts and they always just start flipping that fraction, flipping that fraction, flipping the fraction, but then they get to one where the fraction's not with the variable, and so you end up flipping the other number. And then people go, how come they didn't flip the fraction? Well, because they're really not understanding what they're doing. They're always dividing by the one that's by the variable, and that's the one that ends up getting flipped.